I'm late! Oopsie. Okay, hello. What's up? My name is Juan Miguel, and today we are gonna do some physics things. We're gonna do some physics. Transition. What you're gonna need are two glasses. I don't care if they're the same height. They just need to be elevated. One of them needs to be elevated, and the second is a tube. Well, I mean, you can use like this tube for like a small demonstration, but it's too small. So I got a bigger tube. Yeah, this is for asthma, but like it's fine. It's good enough. I don't want to spend any more materials on getting something, so this is like the cheapest option I can find. And something to suck the water. I'll use a syringe. You can use your mouth, but yeah. Hi, I'm back. So, what you're gonna need are the two glasses of water I mentioned a while ago. One should be elevated. I'm using this for elevation. You could use literally anything. I did use my laptop, but I failed this experiment 3 times already since the tube was too long and it sprayed everywhere. I think my laptop is broken. But anyways, you'll need to suck the water out of this. You can use the syringe, but you can also use your mouth. It's a lot easier. And then there we go. Okay, so how the siphon works is that I broke it. So how the siphon works? This is the siphon. Look, you can see clearly that like there's water coming out of it, even though the thing is like that. It's gonna be. Before explaining that, how the siphon work is that a siphon is a tube that allows liquid to travel upward above the surface of the original reservoir. Then, it goes to the downward level without using a pump. When a certain amount of water moves over the bend in the siphon, gravity pulls it down on the longer leg, which lowers the atmospheric pressure in the bend of the siphon. So, my other voice probably did the explanation here. That was unscripted. So, basically, the only time this thing will stop is when this water is done, or this like has an equal level. And this, oh my god, I'm making a mess everywhere. And you can also stop it by just lifting this, or like removing the water here. That's basically the siphon experiment. Now I got water here. Bam! It's nighttime. 8:05. Anyways, now let's continue for this video. Let's talk about the variables in this experiment, this siphon experiment. Oopsie. There are multiple independent variables and dependent variables in this experiment. One of them is this tube, actually, the area of this tube, or this circle. The reason why this is important, or this is an independent variable, is because it affects the speed of the fluid, or how fast the fluid moves, or the velocity of the fluid. The continuity equation, or like the Bernoulli equation, the smaller the area, the faster it moves. Because area and velocity are inversely proportional to each other, just like velocity and pressure. They're both inversely proportional to each other. So the smaller the area of the diameter, or the smaller the area of the circle, the faster that thing moves. Oh my god, the lighting sucks. But yeah, that's basically the first. The second is the height of the container, because how high the thing is affects how fast the liquid travels. Because the influence of gravity, like the 9.8 thing, the 9.8 is an acceleration, not a constant speed. So the longer it is, the faster the thing moves. This, like imagine having this siphon. It's small. It only affects a bit of the speed. But if you made it longer, the speed increases. So, what are the dependent variables on this study? The dependent variables are, one, how fast the fluid goes, or what is the velocity of the fluid, just like what I said. Hold on, you're too fast, slow down a bit. Said a while ago, the velocity of the fluid is the thing that gets affected, so therefore it's a dependent variable. And the second one is the pressure affecting the fluid in the siphon, because pressure is inversely proportional with velocity, and velocity is also inversely proportional with area. You will also affect the pressure that's going on in the system. So that's a lot of light. Let's talk about the errors of this study. You know what? I kind of don't like this lighting anymore. Let's change the lighting. Okay, so what are the errors of this study? Well, one, what if the diameter of the tube is uneven? Fortunately, this is medical grade. This is for asthma. I wasted a med. Errors of the thing is that if the asthma is different, if the diameter of this tube will be inconsistent, then the pressure and the velocity of the tube will be inconsistent. Okay, the second error is that if you use other liquids, or like example, if this is water, the surface tension will be different. So if you use like a long polymer chain fluid, for example, polyethylene glycol, it's gonna be a part of an error, because if I use water, the speed will be different between that fluid and this, because it's the density. The density is also part of the equation. Well, to understand this better, let's look at the Bernoulli equation as you see here. Well, what is the Bernoulli equation? It is a fundamental principle in fluid mechanics or dynamics that describes the relationship between the pressure, velocity, and the distance or height of the fluid in a steady flow. It's named after the Swiss mathematician Daniel Bernoulli, and the equation states that in a streamlined flow of a fluid, the total mechanical energy per unit of mass of the fluid remains constant along a streamline. This means that if the velocity of the fluid increases, the pressure decreases, and vice versa, as long as there's no external work being done on the fluid and no significant loss due to friction. Mathematically, the Bernoulli equation can be expressed as this equation. Well, that was a lengthy explanation, huh? Well, thanks to my other self back there, where he explained everything about Bernoulli's equation, we were able to understand it. Well, anyways, that's the end of the video. I hope you enjoyed it, and I hope you've learned something from this SIPHON experiment. Judging from the viewers of this thing, they're probably not gonna learn anything since they've already taught me this. So, anyways, better luck next time. Peace.